the two-line notation is somewhat lengthy, and a very handy way for writing permutations is as a product of disjoint cycles. So how does this work? Let's write this permutation here as a product of disjoint cycles. We start with the number 1, and then we see here that 1 is mapped to 6. So we write 6 here. And then we check where 6 goes to. 6 is mapped to 3. So we write 3 here. And 3 is mapped to 1, but 1 is the first number in this cycle. So we just close the parentheses here. So each number is mapped to the next, and the last is mapped to the first. Now 1, 3, 6. The next number we don't have yet is 2. 2 is mapped to 5. So we write 5 here. And 5 is mapped back to 2. So we can just close this here. And now we have 1, 2, 3, but 4 we haven't seen yet. So 4 is the next thing we write here, but 4 is mapped to 4. So we close this immediately. And we usually omit 1 cycles. So we would write this as the 3 cycle, 1, 6, 3, and the 2 cycle, 2, 5. And now since they are disjoint, no number appears in several cycles, it doesn't matter in which order we write them because they don't interfere. In general, if we have cycles with number appearing several times, we will read them from right to left, like functions acting on something. And we see this in a minute. Okay, but here it doesn't matter in which order we write them. Also, it doesn't matter if we cyclically permute the numbers inside a cycle. So 1, 6, 3 is the same as 6, 3, 1, and it's the same as, what is that, 1, no, we had that before, 3, 1, 6. But it's different from 1, 3, 6. So we can cyclically permute the numbers inside a cycle because each number is mapped to the next one and the last one to the first. Now we can write every L cycle as a product of 2 cycles, of L minus 1, 2 cycles. And they are not disjoint then. So how does that work? Let's say if we have this 4 cycle here, 1, 2, 6, 5 maybe, and we can write this as 1, 5, 1, 6, 1, 2. And let's see whether this worked. And now we also see how we can calculate with cycles. So let's see where 1 goes to. We enter this expression here from the right and see that 1 is mapped to 2, and then nothing happens to 2 here and nothing happens to 2 here. So in the end, 1 is really mapped to 2 for the whole expression. What happens to 2? 2 is mapped to 1, and here in the next step, 1 is mapped onto 6, and then nothing happens to the 6 here. So overall, 2 is mapped to 6. And finally, nothing happens to the 6 here. 6 is mapped to 1, and 1 is mapped onto 5. So it works out. In total, 6 is mapped to 5. And what happens to 5? Here nothing happens to 5, here nothing happens to 5, and here 5 is mapped to 1. This means we just close the parentheses here.